Hello again. Okay, so we're going to start off on page 226 in the page 226 in the textbook. Now for this one, last class we talked all about corresponding sides and being congruent figures. So if we have corresponding sides or corresponding angles of two figures, then those figures would be congruent. And I also mentioned that there are little tricks we can do to make this a little bit go quicker. We don't need to do all of them. And today we're going to start with the first two of 5 different ones. Now, the first one is on page 227. So next page, just page over. And the first one is called side, 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 or SSS. Basically what this says is if all the sides of two triangles, all the sides of the two triangles are congruent, then the triangles are congruent. So looking at a picture, if I have this picture here and I have that this is congruent to this, that is congruent to that, and these three are congruent. So let's just pick some random letters, D, E, and F, and X, Y, and Z. So I have that DE is congruent to XY. XZ is congruent to DF. And finally, FE is congruent to YZ. So if these three are congruent, so if these three are congruent, then triangle DEF would be congruent to triangle XYZ. I forgot the triangle mark. Alright, so that's basically SSS. Now let's try proving this. Let's actually go through a small little proof of this. So I'm going to make a kite like this. I'm also going to draw a line that goes like this. I'm going to label some points. So let's say that this is B, this is C, this is F, and this is D. And in the picture, they're going to tell me that this is congruent to that, and that is congruent to this. We want to show that these two different triangles are congruent. So we want to prove that triangle BDF is congruent to triangle BDC. BDC is congruent to BDF. So if, or sorry, not if, I'm going to say given BC is congruent to BF, and CD is congruent to FD. We need to prove that triangle BCD is congruent to triangle BFD. Alright, fairly simple. Our first two statements are just going to be one, this is here, given. This is here, given. So our first two statements, so we're going to have 1, BF, and then congruent to, for congruent, I'm going to say that it's CON, congruent to BF. And then for 2, I'm going to say that CD is congruent to FD. Now, the reasons for this is given, and the reason for this is also given. And then, what can we show? What do we need to show in order to do this? Remember, we're doing this by SSS, so we need that third side. So in the top triangle, we have this side BD that is not congruent to anything. And in this bottom triangle, we have again this BD. So we need to show that is BD congruent to BD? Well, yes, it is. And the property we're going to use is reflexive property. And then that's not it. We also need to, our last line should always be this here. So our last line is going to be triangle BCD is congruent to triangle BFD. And the reason for that would be SSS. So here you have your proofs. This would be the statements, and this would be the reasons. All right, moving on to the next one. Next one is going to be SAS Congruence. SAS Congruence. So for this one, this means you need to have a side, two sides congruent, and an angle, but the angle must be inside the two sides. So where these two sides are going to be meeting. So if two sides are congruent and this is the important part, the included angle are congruent, then the two triangles are congruent. So if I have if AB is congruent to DE, and I have AC congruent to DF, then, oh wait, forgot about the angle. For angle, I'm going to say ANG. Angle A is congruent to angle D. Then triangle ABC is congruent to triangle DEF. I'm going to draw a picture of this. So these are our two triangles. Here's angle A, B, C, D, E, and F. So if, what do I say, AB is congruent to DE, and AC is congruent to DF, and this middle angle, angle A and angle D, then these two are congruent. It cannot be this angle. If we had this side and this side, and any other different angle, we couldn't work. It only works if we have the angle where these two lines, these two congruent lines, are going to meet. So this is important. This only works when you have the angle where the two congruent sides are meeting. Alright, quick question. I'm given this. And I am told that this is congruent to that. What would I need? What would I need in order to make sure that these two triangles are congruent by SAS? Let me label angles. Which two angles am I going to, which things am I going to need in order to make sure that these things are congruent? We're going to need to know that angle ABD is congruent to angle BDC. We know that BD is congruent to BD because of reflexive property. But we need this angle here on the inside and this angle here on the inside. Remember, when you're labeling angles, you have to use 3 different points. The middle point is where that angle is meeting. So in order to make sure that these two things are congruent, we have to have that middle angle. Okay, so that's going to be it for today. In class, we're going to go over different types of ways to use SSS or SAS and when to use them.